Assignment 3V, question 1, which sequence is a geometric progression? Circle your answer. Geometric means that from one term to the next there is a common ratio. What does that mean? Well, let's look at the first sequence. 2 to 4 you multiply by 2, then by 2 again from 4 to 8, and from 8 to 16 you also multiply by 2, so the ratio is the same. Whereas 1 to 3, 3 to 6, they're different. The next ones are different. There are no others with the common ratio. That is the only one where the ratio is the same from one term to the next. Question number 2. Two triangles are similar. Jim says, for similar triangles, corresponding sides are equal. Is it true always, sometimes, or never? What does similar mean? Basically the same shape. If it's a triangle, they should have equal angles. So let's take an example of a triangle. Little triangle like that. You could have a bigger version of the same one, maybe an enlargement. Looks like that. Equal angles, but you can see that the corresponding sides are not equal. So in that case, it's not true what Jim says. But on the other hand, you could have a triangle like this, which is equal angles with the first one and also equal sides. So it can be equal sometimes. So in this case, it's not equal sides. In this case, the corresponding sides are equal. So the answer is sometimes. Number 3, circle. It's supposed to be circle the expression that is equivalent to 3a plus a times 5a minus 2a. 3a plus a times 5a is 5a squared minus 2a. That gives us a plus 5a squared. And you cannot combine those two together. They're different kinds of terms. So we have to leave it like that. And there it is in the answer list. Question number 4. Circle the equation of a line that is parallel to y equals 7x plus 2. Parallel, another way of saying that is that they should have the same gradient. And the gradient of any straight line from the equation is given by the coefficient of x, the number in front of x. So in this case it's 7. So we just have to look for another line, minus 2 there, 7 there, 2 there, and 1 there, although it doesn't show 1. So the only one with the same gradient is that one, gradient of 7. Question 5. In a sale, the original price of a coat was reduced by a quarter. The sale price is now $27.60. Work out the original price. You're asked to work out the original price, so let's call that x. And if it's reduced by a quarter, then it means that what remains is 3/4 of x. And we know the final price after the sale is $27.60. So 3/4 x equals the sale price $27.60. And we try to tidy this up, maybe get rid of fractions by multiplying both sides by 4. I get 3x equals $27.60 times 4, which comes to, I think, $110.40. You can use your calculator. And to get x, you divide by 3. I'll do it by hand. 3 into 11. Let's do it here. 3 into 11 goes 3, remainder 2, 3 into 20 goes 6, remainder 2, 3 into 24 goes 8, so it's 36.80, £36.80 before the sale. Question number 6. You were told the universal set is this set of numbers. R is the prime numbers out of that list. So what prime numbers can we find in that top set. So let's try and write down the members of R. So look for the prime numbers in the list. 17, 19 and 23 I think are the only ones. Similarly, D, numbers whose digits add up to 4. So we've got to look for numbers where the two digits added together come to 4. No. 22, yes, 22, 2 plus 2 is 4. So that's okay, but that's the only one. So I've listed the members of R and the members of D. So now complete the Venn diagram. So D has 22 in it, R has 17, 19 and 23, and all the rest are not in R or D, so they're around the edge here. 15, 16, 18, 20, 21, 24, 25, 26, 27. Next part. One of the numbers is chosen at random. Write down probability that X belongs to R intersection D. So let's look for R intersection D. Intersection means numbers that belong to both R and D. So that is this set here, and in fact you can see there's no numbers in there, so it's just 0. Question 7. A coin is rolled onto a grid of squares. It lands randomly on the grid. To win, the coin must land completely within one of the squares. Anila and Mark each roll the coin a number of times and record their results. Anila, 11 wins, 39 losses. Mark, 23, 77. I think I'll add another column called the total. Anila, 11 plus 39 makes 50 tosses altogether. And Mark comes to 100. Sorry, not tosses, rolling a coin, isn't it? Work out two different estimates for the chance of winning. So Anila, so you've got 11, the chance of winning will be 11 out of 50 total. And Mark, chance of him winning, going to be 23 out of 100. Question 7. Part B, which of your estimates is better? So I'd say that Mark's estimate is better. And the reason for that is that he did 100 trials and Anila only did 50. So he did more trials. Oops, don't know how my pen is going there. It says trials. So he does more trials. And it's always better to do more when you're doing probability. Question 8. Here is the graph of 3x minus 2y minus 4 equals 0 for values of x from 0 to 4. You can see that it goes like this. By drawing a second graph on the grid, work out an approximate solution to the simultaneous equations 3x minus 2y minus 4 equals 0 and x plus 2y minus 3 equals 0. So the first one in those two equations is just the line that we've already drawn. So all I've got to do is try and get the second line. So I'm doing x plus 2y minus 3 equals 0. And I'll choose when x is 0, what is the value of y? I just get 2y minus 3 equals 0 since the x is 0. So y will equal 3 over 2, or 1.5. And another easy point is to work out when y is 0. If I put y equal to 0 in the equation, I get x plus 2 times 0 is 0, minus 3 equals 0. Or taking 3 to the other side, I get x equals 3. So I've got 2 points now. I can put those on the graph. 0, 1.5 is about here. And 3, 0 out there. Draw a straight line between them. And so now we've got to work out an approximate solution to the simultaneous equation. I'm going to label my lines so I know which one is which. 3x minus 2y minus 4 equals 0, and the second one, x plus 2y minus 3 equals 0. It's always good to label everything. Simultaneous equation solution. Now simultaneous means at the same time. So what point at the same time lies on the first line and the second line? There's only one point, which is this one here where they cross over. That point lies on both lines. I'll zoom in a bit to make it easier to read the scale. So the x value of that point is 2, 4, 6, 8, 1.8. And the y coordinate of that point going across is approximately 0.246. So my answer is that. Don't worry too much about the accuracy. It does say an approximate solution. Question 9. Write as a product of its prime factors, or written as a product, we get 540 equals that. Now you've got to do the same thing for 168. I learned how to do these a long time ago by a standard way of laying out. 168, put a nice long line down there, and I say I can divide by 2. 2 into 16 goes 8, 2 into 8 goes 4, and then 2 into 84 goes again, and that gives me 42. 2 can go in again, gives me 21. 2 doesn't go anymore, but 3 does, so I can divide by 3. 3 into 21 goes 7. The only thing left is 7 into 7 goes 1. So 168 is equal to 2 times 2 times 2, which is 2 cubed, times the next factor is 3 times 7. And that's my answer for 168. Part B, work out the value of the highest common factor of 540 and 168. We've got both of these numbers as a product of their prime factors. So we've got to find the highest common factor. So we've got to see what is in common between them. I think I'll write 540 up here, and then I'll write them out in long form. So 2 squared, I'll write it as 2 times 2. And 3 cubed is times 3, times 3, times 3, and then times 5. Makes it easier when we look for the common factors. And 168, I've just worked it out. For my answer is 2 cubed, which is 2 times 2 times 2, times 3, times 7. Now I can compare the two answers, or two numbers, and look for common factors. I've got 2 times 2 in the first one, and I've got 2 times 2 in the second one, so that's common. Then I look, I've got a single 3 there and a single 3 there. I can't have any more 3s because there's no 3s in 168, and there's no 7s and there's no 5s, which are common, so I'm just left with what I've underlined there, 2 times 2 times 3, or in other words, 12. Question 10. At a school, the number of boys compared with the number of girls is in the ratio of 7 to 5, and there are 48 more boys than girls. So work out the total number. So let's see. Let's suppose that the number of boys is 7x. Since I know the ratio is 7 to 5, I'll call it 7x. If that's the case, then the number of girls would have to be, sorry, what else doing that? The number of girls would equal 5x, because they've got to be in the ratio of 7 to 5. Okay, now it says there are 48 more boys than girls. So boys minus girls should equal 48. So 7x minus 5x should equal 48. 2x equals 48. Divide by 2 on both sides. X equals 24. Work out the total number of students. Well, the total number of students, 7x boys, 5x girls, we add them together and get 12x for the number of students, which is just 12 times x I've just worked out is 24. So we'll get an answer finally of 288 for the number of students in the school. Question 11. Circle the equation with roots of -2 and 3. Root means x is equal to -2 or x is equal to 3. Now if x equals -2, another way of writing that is to say that x plus 2 equals 0. And the second one, x minus 3 equals 0. That's just different ways of saying the same thing. But now the useful thing here is that if x plus 2 is 0 and x minus 3 is 0, then their product must be 0. So I'm looking for a product of two factors, x plus 2 and x minus 3. And I see that it is this one here. Question 12. R equals x cubed over y squared. X is 2.4 times 10 to the 7. Y is 6.5 times 10 to the power 3. I'll write them down, and then I think I'll do it by working out 2.4 times 10 to the 7 in the long form by actually multiplying by 10 7 times. So I've got moved the point 7 places, 1 to get 24, and then another 6 places, 1, 2, 3, 4, 5, 6. So that's the top one cubed divided by, and here 6.5 times 10 to the power 3, move it once is 65, and then 2 more after that. So we get that divide to the power 2. Now you can use your calculator. I use the x to the power y button for the cube, or you may have a special cube button on your calculator, and work it out. I'll write down the first few figures of accuracy. I won't write all of them, and so on. And the way my old calculator gives it, it also gives a little 14 in the display, raised about. Yours may actually say times 10 to the power 14. So this is standard form. We've got two significant figures at the beginning, so I think I'll just give my answer to two significant figures. So 3.27 becomes 3.3. times 10 to the power 14 from the calculator there. And question 13. Two spheres have a radius in the ratio 5 to 4. Circle the ratio of their surface areas. Radius is a distance, so it's just a straightforward scale factor of 5 to 4. But the surface area, that is involving areas, and the area scale factor is always obtained by taking the distance scale factor and squaring it. So if we square that scale factor, we get 25 to 16. And we look for that in the answers, and there it is. Finally, question 14. Pattern is made from two similar triangles. Show that the shaded area is 320 square centimeters. So we've got the big triangle, and we know that the big triangle has a base of 30 and a height of 24, so I should be able to work out the area of the large triangle is equal to a half, I think I'll write 0.5, it's neater with the computer, times the base, which is 30, times the height, which is 24. And if you work that out, it comes to 360 square centimeters. Now, what do I know next? We are told that the smaller triangle is similar, because it says two similar triangles. Small triangle is similar to the large triangle. It doesn't look similar, and that's because it's been rotated around, it's turning upside down. Maybe it's easier if you imagine it rotated back, it would look something like, the small one would look something like this. Then you can see it looks more similar to the big one, with the base of 10 instead of a base of 30. So the ratio of the bases is 1 to 3, 1/3. So the scale factor is 1/3 there, but we know that they are similar and we want to find the new area, so it should be straightforward to find well, let's write it down. The area scale factor we've said is 1/3 squared, which equals 1/9. So therefore, the area of the small triangle will just be 1/9 of the area of the big triangle. And we know the big triangle is 360. So we can just put 360 there, 1/9 of 360, which comes to 40. So the question, again, is asking us about the shaded area. So the shaded area will just be the big triangle minus the small triangle. Big one is 360, small one is 40. So it's just 360 minus 40. 320 is an area, so we should say square centimeters just to get the units in as well. We should always put units. And you can see that is what we were asked to prove.